Hi viewers, welcome to Level Solution. Today we are going to see about Five-Level Multilevel Inverter with the PWM and the Nearest Level Modulation technique. First you have to discuss about mode of operation of Five-Level. This is a circuit diagram for that, topology diagram for that multi-level inverter, Five-Level Multilevel Inverter. It consists of single hot switch with the single bidirectional switch. This is single hot switch with the single bidirectional switch and with having two voltage source. By using this topology, we can generate five level output. This is the switching table for a different level. First, you consider level VDC. For example, you consider the source voltage V1 which is equal to VDC divided by 2, and then V2 also VDC divided by 2. We consider V1 VD equal to VDC by 2. So if you want to generate VDC, we need to operate the switch S1 and S2. When we operate S1 S2 switch, that will be closed like this. Then the total voltage, that means V1 plus V2 will be appear across the load. I told V1 VD equal to VDC by 2, we will get the VDC. Further, you need to turn on S1 and S2. The remaining switch will be 0. So next you have to consider for level VDC by 2. For VDC by 2, here we need to turn on switch SA and then S2. When turn on SA and S2, the circuit will be closed like this. Then the voltage V2 will be appear across that load. Now to get VDC by 2, we need to turn on switch S2 and SA or plus pi. When we want that 0 voltage, we can turn on S2 and S2. The load will be short circuited. We will get the 0 voltage across that load. Or else we can turn on S1 and S3 and turn on S1 S3. So here also the load going to be short circuited. The voltage across that load will be 0. For minus VDC by 2, we need to turn on S3 and S5. That means the circuit will be closed like this. That means the voltage will be appear across the load with the negative polarity. The load having minus VDC by 2. When turn on S3 and SA or S5. For minus VDC by 2, we must turn on S3 and S4. Then circuit will be closed like this. Then the addition of these two voltage V1 plus V2 will be appear across the load with the negative polarity. We get minus V. This is operation of this five level inverter. So here in order to turn on that switch, you have to use two type of technique: nearest level modulation as well as pulse width modulation. Two technique going to be used in this in order to turn and turn off the switch. Let's see the implementation diagram in the MATLAB. This implementation diagram in MATLAB for this five level multi-level inverter. We has two sources, and then this is nothing but the bidirectional switch, and then this is output, and this is nothing but load. Next you have to see about nearest level modulation technique. Nearest level nothing but just you have to compare sinusoidal waveform with some constant value. Based upon that, we need to control that, we need to turn on turn off the switch. That means we need to compare that sinusoidal waveform with some level of voltage. Here I have to compare with a different level of voltage like 0.75, 0.25, minus 0.25, minus 0.65. This is the different level, and here I am going to compare. Based upon that comparison, we will get a five level output. The motor. Next, I am going to explain step by step. Here you can see that this is sinusoidal waveform, and sinusoidal waveform cross above the 0.25, we will get a first level output. You can see that the sinusoidal waveform cross above 0.25, we will get the first level output. That means we can say that the VDC by 2. When then the sinusoidal waveform cross above 0.75, so we will get the second level output. That means VDC. When that sinusoidal is less than 0.75, it goes to first level. Same way, we will get the multi-level out. Crossing above 0.25, you will get first level. It crossing 0.75, you will get the second level. Is below 0.75, it goes to first level. Below 0.25, it goes to 0 level. Is below minus 2.5, it go to minus first level. It goes to below minus 0.75, it goes to minus second level. Based upon that sinusoidal and the level comparison, we will get that the output at output. This is nothing but the nearest level model. So nearest level, that means we are going to compare sinusoidal with some constant based upon comparison greater than and less than. So it will generate the pulse to get the level of output at the inverter, a different level. This is nearest level modulation. Next, I'm going to explain about PWM technique. Same concept you have to use. That mean here we are going to compare that sinusoid. That means this is modulating signal with the carrier. This is logic for that generating pulse. So you have to compare that triangle with the sinusoidal with a different level. You will get a pulse with PWM pulse to turn on turn off the switch. Here also you can see that it change that selection nearest level modulation to PWM modulation. You will see that if the sinusoidal way in between 0 to 0.5, you will get a one level of output. This is nothing but pulse width modulation. If suppose I'm going to change the modulation index, here you can see the modulation index. Here I kept it to 0.9. I'm going to change to that value to 1. What will happen to that level? It goes to our modulation point. Here you can see that the difference when modulation index goes to 1. So you get the difference. I'm going to change the modulation index to 0.7. Let's give it a check that one. 0.7. When 0.7 also, the number of level is equal to 5. I am going to change that modulation index equal to 0.5. 0.5. Now see that changing the modulation index equal to 0.5, the level change to 3. I'm going to keep on decreasing that modulation index to point. I will consider this level. When I'm changing that modulation value, you will get that inverter output here. You can see that this is inverter output, this is inverter current. Now I'm going to change the modulation index to 0.5. Now you will see the difference in the current. The current going to be increased because of changing modulation index. It changed from 0.2 to 0.5. We will see the difference in the current. Now we can see that variation of the current because of increasing the modulation index. Now I'm going to change that modulation index to 0.7. Level also change, current also. So suppose I'm going to change modulation index equal to 0.9, 0.9. Here also current change to maximum value. It's a variation of modulation index and a change in voltage, inverter voltage current. I'm going to change the selection to 1. That means I'm switch out from BWM to nearest level modulation. You will see the difference. Now you see the difference. We change to nearest level modulation. Right? And now you see you'll get some current changes in the inverter current also. I'm going to change the modulation text to 0.7 or 0.5. You will see the changes in the level and changes in the current also. And when you change modulation index equal to 0.2, it's less than 0.25. Less than 0.25, all switch will be off condition. So you will not get the output. So I'm going to change this modulation index to 0.3. You will get some changes. Now you see that this greater than 0.25, so we'll get this 3-level output. This is the operation of 5-level multi-level inverter with PWM and nearest level modulation technique. Thanks for watching our videos. Kindly subscribe our channel and also click bell icon for upcoming notification. Thank you. Thank you so much.